Between NASA and SpaceX and the future of moon exploration, NASA chose Elon Musk's private company to build the next generation lunar landers.
Every space channel on Earth is running the same story right now. NASA just exposed a terrifying 100-foot elevator problem on SpaceX's Starship moon lander. And the reality is somehow worse than that headline suggests, because NASA never actually used the word terrifying. On March 10, 2026, NASA's Office of Inspector General published report IG-26-004. No emotional language, no dramatic adjectives, just a mathematical statement. Open quote. Currently, there is no other method for the crew to enter the vehicle from the lunar surface in the event of an elevator failure. End quote. One sentence. No redundancy. If that elevator jams, astronauts are stranded 11 stories below the only airlock with no way up. So today we walk through what the formal NASA documents say, what SpaceX has built, why Starship's height made this problem inevitable, and why NASA just executed one of the biggest pivots in Artemis history to buy themselves 2 more years. This is episode 70. Drop a rocket emoji in the comments if you want the facts from the actual audit, not the hype. The exact dimension. Let us establish the physical reality first. Starship HLS stands approximately 171 feet tall, the equivalent of a 14-story commercial building. The vehicle is 9 meters wide, 29.5 feet across, with massive liquid oxygen and liquid methane propellant tanks stacked at the bottom and the pressurized crew cabin perched near the top. The exact vertical distance from the crew cabin's airlock egress hatch to the lunar surface is 115 feet, 35 meters. The OIG report notes the elevator spans a descent taller than the Statue of Liberty from heel to head. Conflicting figures in early reporting, ranging from 98 feet up to 164 feet, come from confusing overall vehicle height with airlock location. The correct number is 115 feet. And here is the first critical framing point. No NASA official, in any report, audit, or formal finding, has ever called this problem terrifying. That word comes from media commentary. The only recent use of the word terrifying by a senior NASA official was Administrator Jared Isaacman describing the emotional experience of an astronaut's family watching a rocket launch. The actual formal concern is not emotional, it is mathematical, and that is what makes it serious. The engineering solution. If you want more breaking space industry coverage like this, now is the moment. 98% of people watching are not subscribed. Fix that. Subscribe, turn on the bell, and let us continue. Astronauts cannot climb a 115-foot ladder in pressurized EVA suits while carrying equipment and lunar samples. SpaceX and NASA abandoned the static ladder entirely. The finalized solution is an external mechanical vertical rail elevator. A motorized basket travels along a track mounted directly to the exterior hull, transporting crew and cargo between the airlock deck and the lunar regolith. In late 2023, SpaceX built a subscale functional mock-up at its Hawthorne headquarters. NASA astronauts Nicole Mann and Doug Wheelock conducted human-in-the-loop testing using flight-representative pressurized EVA suits, validating suit mobility, control panel accessibility, and compatibility with the Axiom Space AXEMU spacesuits. SpaceX has emphasized redundant mechanisms. If the primary motor fails, backup winch systems are engineered to manually haul the basket to safety, but every redundant system is still part of the same external apparatus, exposed to the same lunar thermal cycling, abrasive regolith, and micrometeoroid environment. What the OIG actually said. The most authoritative current assessment is that March 10th OIG report, published as an independent audit evaluating the Human Landing System program for Congress, and it is blunt. The report formally classifies the Starship elevator as a critical vulnerability. The exact language, again, open quote. Currently, there is no other method for the crew to enter the vehicle from the lunar surface in the event of an elevator failure, end quote. Because the HLS program requires at least single failure tolerance to catastrophic events, the lack of a secondary ingress route violates standard NASA redundancy postures. The audit confirms NASA's HLS program is tracking the elevator as a top risk and is actively pressing SpaceX to develop alternate means of vehicle ingress. The report also criticized NASA itself for failing to mandate test-like-you-fly principles. NASA is not currently requiring SpaceX to operate the elevator during the uncrewed lunar landing demonstration. The OIG flagged that as a missed opportunity to validate the mechanism in actual lunar thermal and abrasive conditions before human lives depend on it. The report included a second major finding that rarely makes headlines. Open quote. Given Starship's height of 171 feet, about the equivalent of a 14-story tall commercial building, there is a risk that its momentum will continue after landing, causing it to tip over. End quote. NASA's tilt tolerance requirement allows the lander to settle on a slope of up to 8 degrees. On a 17-story vehicle, an 8-degree tilt displaces the apex significantly, and if the vehicle is leaning, the elevator rails are no longer perfectly vertical. The basket must navigate a slanted track without binding, twisting, or scraping at exactly the moment astronauts are trying to reach the surface. The ASAP warning. The OIG is not alone. The Aerospace Safety Advisory Panel, established by Congress after the Apollo 1 fire, released its 2025 annual report on February 15th of this year. Their conclusion is equally stark, open quote. Our fact-finding this year has driven the ASAP to the conclusion that the Artemis III mission, as baselined, cannot be accomplished with appropriate margins of safety. The development and test progress necessary for a version of Starship that has not yet flown in time to support a human lunar landing mission within the next few years appears daunting and, to the panel, probably not achievable. End quote. That is a formal statement from a congressionally established safety panel chaired by retired Lieutenant General Susan Helms, herself a former NASA astronaut. In August of last year, ASAP members, including former flight directors Paul Hill, Kent Rominger, and Charlie Precourt, personally visited SpaceX's Starbase facility. They were impressed by the manufacturing tempo. They still formally warned the Starship HLS schedule was, quote, significantly challenged, end quote, and could be years late for the original 2027 timeline. The full risk stack. The 115-foot descent also faces compounding lunar physics risks. If the drive mechanism jams from thermal expansion, motor failure, or rail deformation, astronauts have no alternative to reach the airlock. NASA has formally stated the agency does not have the capability to rescue a stranded crew from the lunar surface. The loss of crew threshold is 1 in 40 for lunar operations. Those are extremely tight margins. Lunar regolith is notoriously abrasive. Apollo astronauts found it fouling suit zippers within hours. The external tracks, rollers, and winches will be hit with massive plumes of regolith from the landing thrusters before the elevator is even deployed. During cislunar transit, the exposed rail can also be struck by micrometeoroids, potentially deforming it for the rest of the mission. And the redundant electric motors, shielded cables, and backup winches all draw from finite power reserves already burdened with cryogenic propellant storage. The Apollo baseline. The Apollo lunar module stood just 23 feet tall. The crew cabin sat directly above the descent stage. Astronauts stepped out a small hatch onto a platform and descended a fixed aluminum ladder roughly 9 feet to the surface. Even at that height, the descent was demanding in pressurized suits. Neil Armstrong had to execute a 3-foot jump from the final rung. Apollo 17 Commander Gene Cernan reported near-total exhaustion reclimbing that short ladder after multi-hour traverses. Starship's 115-foot drop is over 12 times greater. If a 9-foot ladder was a rigorous challenge in 1969, an impassable 115-foot vertical face is an absolute barrier to human survival if the automated system fails. Why Starship is so tall? Here is what most commentary gets wrong. The elevator is not a design flaw, it is a geometric consequence of what Starship fundamentally is. Apollo was purpose-built as a lightweight, expendable, 2-stage vehicle. The descent stage was left on the moon as a launch pad for the ascent stage, which naturally kept the entire vehicle short at 23 feet. Starship is built around total reusability. It is not a bespoke lunar module. It is a heavily modified upper stage of a super-heavy orbital launch vehicle, operating as a single-stage lander that carries descent engines, ascent engines, and all propellant for the round trip in one towering silo. SpaceX also uses in-space cryogenic refueling. Starship launches to Earth orbit, gets refueled by tanker flights, then departs for the moon with enough capability to deliver 100 tons of payload in a single trip. That payload capacity is transformative. It is also what forces the vehicle to be 17 stories tall, with the crew cabin stranded atop the methane and oxygen tanks. The elevator is the inescapable geometric penalty of adapting a 100-ton interplanetary transport into a lunar lander. The Blue Moon comparison. NASA does not rely on a single lunar lander. The agency selected 2 separate providers, and the design divergence is staggering. Blue Moon Mark II stands roughly 53 feet tall, less than a third the height of Starship. Because Blue Moon is optimized specifically as a dedicated lunar lander, Its heavy liquid hydrogen and liquid oxygen tanks are arranged to keep the center of gravity exceptionally low. The pressurized crew cabin sits near the bottom of the vehicle, not at the apex. That single architectural choice eliminates the elevator problem entirely. Mock-up testing at NASA's Neutral Buoyancy Laboratory demonstrated a walk-on side entrance where crews descend a short set of stairs roughly 6 feet to the surface. The OIG report draws the comparison explicitly. Open quote, "Unlike astronauts aboard Blue Origin's lander, who can use stairs to reach the surface 6 feet below, crews aboard SpaceX's lander will have to ride an external elevator some 10 stories down." End quote. Blue Moon has its own challenges, including unsolved zero boil-off cryogenic cooling and New Glenn's limited flight record. But if an astronaut slips on Blue Moon stairs, it is a manageable fall. If the Starship elevator jams 100 feet in the air, it is an architectural crisis. The Artemis III Pivot. The accumulation of these technical risks hit a breaking point in early 2026. On February 27th, newly confirmed NASA Administrator Jared Isaacman, flanked by Associate Administrator Amit Kshatriya and Acting Associate Administrator for Exploration Systems Development Lori Glaze, announced a sweeping overhaul of the Artemis architecture. Artemis III, celebrated for years as the mission that would return humans to the lunar surface, was officially stripped of its landing mandate. It is now a low Earth orbit test flight targeted for mid-2027. Astronauts will launch aboard the Space Launch System in the Orion capsule, rendezvous with Starship HLS, Blue Moon, or both, and perform integrated checkouts of life support, communications, and propulsion. What they will not do is commit to a lunar descent. Isaacman at the press conference. Open quote, "With credible competition from our greatest geopolitical adversary increasing by the day, we need to move faster, eliminate delays, and achieve our objectives." End quote. And from Kshatriya. Open quote, "There is too much learning left on the table and too much development and production risk in front of us." End quote. The actual lunar landing has been pushed to Artemis IV, potentially Artemis V, in 2028. NASA has effectively bought SpaceX and Blue Origin 2 additional years to refine their descent mechanisms. The China problem. There is one more layer to this, and it is the one NASA cannot wish away. China intends to land taikonauts on the lunar surface by 2030 using their own crewed lander. Unlike Starship, Lanyu embraces the traditional Apollo-style architecture. It weighs approximately 26,000 kilograms, uses separate descent and ascent stages, and jettisons the descent stage shortly before touchdown. The crew cabin sits very close to the lunar regolith. Taikonauts descend via a standard static ladder. China has already constructed full-scale 150-meter test gantries on Earth to simulate Lanyu's descent in tethered 1/6 gravity conditions. If SpaceX cannot validate the elevator's reliability, NASA's options are all bad. Force a redesign and lose the race to China. Issue a formal safety waiver, or sideline Starship for Blue Moon, which carries its own unproven technologies. The February pivot buys time. It does not solve the underlying problem.